Alright, in this final video we're going to talk about simplifying expressions. And to simplify these expressions, we're going to put everything we've learned over multiplying monomials to use. We're going to use product of powers, power of powers, and power of products. So let's just jump in and take a look at this. So to simplify a monomial expression, we're going to write an equivalent expression in which there's three things that have to happen. The first one, each variable base is going to appear exactly once. The second condition, there are no powers of powers. We've simplified those. And third, all fractions are in simplest forms. Now you're not going to have fractions in all, but some you will, and just simplify them so they're in simplest form. So let's take a look at this. Here we have an expression, and it says 5x to the second power y raised to the second power times 2xy to the third power z raised to the third power, and then that multiplied by 4xyz. So there's some power of powers in here, or powers of product, so we're going to have to use distributive property. So I know this exponent of 2 is going to distribute across this product. And here I know this exponent of 3 is going to distribute across this product. So let's take a look at the first one. When we simplify it, we're going to have, since this is raising it to the second power, we're going to have 5 to the 1 times 2 power. We're going to have x to the 2 times 2 power, and y to the 1 times 2 power. On our next expression, we're going to have 2 to the 1 times 3 power, because we're raising all of this to the third power. We're going to have x to the 1 times 3 power, y to the 3 times 3 power, and z to the 1 times 3 power. Now we're going to go ahead and bring down that last product because we just want to keep track of it. Even though they didn't raise it to a power, we want to keep bringing it down with this step by step so we don't lose it. When we go to simplify these, we're going to have 5 to the second power, x to the fourth power, y to the second power, times 2 to the third power, x to the third power, y to the ninth power, z to the third power, times 4xyz. Now we're just going to, this is just basically multiplying powers, and they have this, we're going to look for same bases, so we're going to do some grouping. We're going to group the coefficients, and we're going to group the variables, the like variables, together. Now we can go ahead and do a little simplifying before we do our next step. We know that 5 to the second power is 25. We know that 2 to the third power is 8. So in this next step, I can go ahead and say 25 times 8 times 4, so I've got my coefficients together. Next, I take the variable x. I have x to the fourth power times x to the third power times x to the first power. So that's going to be x to the 4 plus 3 plus 1 power. Then we have y to the second power times y to the ninth power times y to the first power, which would be y to the 2 plus 9 plus 1 power. Then last but not least, we have z to the third power times z to the first power, which would be z to the 3 plus 1 power. So we go ahead and find those powers, and we've got 25 times 8 times 4 is 800. So we have 800 x to the 8th, y to the 12th, z to the 4th. I hope you found this informative and it answered a few of your questions. And as always, if you're struggling or have any questions, be sure to reach out.